moving on to our sixth presentation. It will be on how large language models are transforming machine paraphrase plagiarism, and it will be presented by Jan Philip Wall.
Perfect. So thanks everyone for joining. My name is Jan, and I'll be your speaker today to talk about the challenges of the future for paraphrase plagiarism detection. So our lab has been working on paraphrase plagiarism for over a decade now. And there's many researchers who are into this field, mostly in information retrieval applications. And there's good reason to spot plagiarism automatically. There's research funding being given to people without having done the original work. There's really powerful positions being given to people that have plagiarized whole dissertation theses. One of the most popular examples is former Defense Minister Gutenberg in Germany. He has plagiarized his thesis from a different language, and you can map that almost one-to-one to the original thesis. So there's a strong motivation why we want to detect and flag plagiarized content in general. And in the last couple of years, we've been seeing this one trend, this one thing that might influence plagiarism detection for good. It might transform the entire field, and that is the use of large language models. So you've probably heard of ChatGPT and those models. I mean, they're quite popular now. And these models can be asked simply to rephrase content from other works. So I can go to the Bird paper in this example, I can rephrase the abstract, and I can use it in my own work. If it makes sense, I can even plagiarize other paragraphs from other works. And this is a big threat to academic integrity. There's been a study by the European Network of Academic Integrity that 1/3 of the students already use similar tools, not ChatGPT, but paraphrasing tools to do their assignments and those things. So in this study, we want to raise awareness to the problem. We want to show how much of a problem it is, not only to automated solutions, but also to human annotators. So what we did in this study is we wanted to have a proxy of documents that we use for plagiarism, for automated plagiarism using language models. And we went to Wikipedia, archive, and graduation theses. Wikipedia, we used the feature article category. Those are articles which have been authored quite a bit by experienced authors. We've been to the Archive XML project, used papers from different disciplines like physics, computer science, you name it, mostly STEM fields. And then also graduation thesis from bachelor, master, and PhD level from students of our university at that time. And basically, we wanted to have an approach that is fairly easy to use, but still gives us great results in terms of generation. So we use few-shot prompting. It's nothing too fancy, but you basically have a bunch of human paraphrases, known paraphrase cases by humans, and then you have your prompt and you generate on unseen data, which is the paragraphs of these documents. So this gives already some convincing results. Some of these texts are already really similar while using different words or structures. Some of them have a low semantic preservation. For example, in this example, you have an event which is in a span of 2 years. The model tries to split that into 2 different events, and then it messes up with the date. You can probably fix that easily by some named entity recognition or not paraphrasing those parts of the text, but we'll see more on this later. And there's, of course, some repetition in the examples that we generated. So to keep the semantic meaning of the source text while not using the same words and structures, we used a pretty intuitive approach. We try to reduce the word count similarity or the word-based similarity and increase the semantic similarity. And then you choose kind of like the Pareto front of the both of them. So you don't only optimize over one or the other. And this gives pretty good examples. We'll see later more on this. So to now give you more on how much of a problem that is, we asked basically 3 research questions. 2 of them are on the human component and 1 is on the automated component. So first, can humans identify it still? I mean, that's our gold standard. We want to know if humans are good at it. And then not only to have the binary perspective, but to look at more quality measures. We also asked in which aspect do they agree? And the third part is then, do we have already solutions existing like plagiarism detection software or transformers to classify this? And there's a couple more questions in the paper. It's just a matter of space in the presentation. You can check them out later. So on the first question, we asked 50 people from Amazon Mechanical Turk. We required them to have at least a certain number of hits being performed. We followed some best practices on this. And the first model that we looked at is called SpinnerChief. SpinnerChief is a commercial paraphrasing tool. You can buy it and then you can paraphrase text with it. It's very commonly used. SpinnerChief and SpinBot are two of the most used paraphrasing tools by students. And if we ask humans to classify this, we get a mean accuracy of 82%, which is pretty good. So they can spot this paraphrasing tool. We don't know exactly how it works. It's more of a black box because they don't declare what they use, what technology, but we presume that it's some sort of lexical database and they basically replace synonyms. Sometimes these synonyms don't fit the context, which was also the feedback we got from humans. So they would be able to see if a synonym was not good in the context, that it would probably be paraphrased. If you then use BERT and Roberta, this changes because BERT and Roberta are contextual models and they know which synonyms to replace in the context. So if you mask a few spans in the text, it will be able to probably give really good synonyms in that context. So in this case, the humans struggle way more. They have 65 to 67% mean accuracy. Notice the I don't know assignments also increase a bit. So it's just a bit more uncertain for the human to classify. And then when we scale this, and this is one more experiment in the paper, you can read it, to more parameters, we see this changes drastically. So when you scale models, and if you use autoregressive or sequence to sequence, then also sentence structure can change, syntax can change, and now the humans struggle a lot with this paraphrases. And we did a two-sided t-test here. So SpinnerChief is our control, and then we have the other models being tested. One note, maybe the I don't know assignments also grow, so it's getting more uncertain whether this is a paraphrase or not. So moving from this binary perspective, we wanted to know on which aspects do the humans feel that paraphrase are good or not. So we first established our original baseline on a Likert scale from 1 to 5, again, 50 participants from Mechanical Turk. And we wanted to get first on the original examples because you might assume that those are really high, but there's some technical jargon and some terms that also humans don't necessarily understand. So here we have 3 dimensions: clarity, fluency, and coherence that we measure on. When we go to SpinnerChief, these drop significantly. So humans see that paraphrases from SpinnerChief are not as fluent, are not as clear and coherent as the original examples. But then going to BERT, it's almost matching up to the originals and GPT-3 too. So here the difference is that BERT's coherence is a bit higher. It's probably because the real text doesn't change as much. It's more specific words that change. So the structure keeps the same, which keeps the coherence probably high. And then, I mean, GPT-3 is really good at generating fluent text, which is why the fluency is high, and clarity too. So in the last research question, we were looking at automated solutions from related work, from previous work. Here, we used one of the largest plagiarism detection software called PlagScan. So PlagScan and Turnitin are the largest ones used today. PlagScan gives you a text match of the documents by some source index. And here, we gave a boundary of how much text match is expected to be plagiarism. And most of the time, it's just lower than random chance here. Word2Vec naive Bayes is a strong baseline for traditional plagiarism detection. Here, it cannot match up with the human baseline most of the times. And then if you scale the models again, we see that they get better at detecting these paraphrase cases. One consistent finding we had is that the model that generated the plagiarism was also the best to detect it. And the other finding we consistently had is that when you scale model size, the models become better at detecting it. So there is hope. We just have to find the right methods to detect it. So if I can give you one thing or one message from this presentation, it should be that large language models can already perform these plagiarism cases that humans and machines have problems to identify. So it is already a big challenge. We just never tested it that way. And especially the field of academic integrity and information retrieval now see that a lot of the NLP applications come into their field and a lot of these big models are being used. So we have the data set, it's on Hugging Face. You can download it with 1 line of code. We will also probably release it on Zenodo soon. We have all the evaluation also there. And yeah, so far GPT-3 is the best model we tested, but you can probably extend this to Bloom and all the other large language models are there. Some of the limitations. So what we didn't do in this study is we didn't compare real plagiarism cases to the artificial ones. When you go to these plagiarism databases, like PAN is one of the biggest ones, you will see that most of them are also artificial. That's simply because there's not too many known ones from humans that we have. So it's a matter of detecting the real human cases. And in the future, we still want to compare them to the artificial cases. In this study, we also only did intrinsic analysis, no extrinsic analysis. So we looked only at the text level within our corpus, not to a match index, for example, across all of the research papers on Semantic Scholar. You could do that to find text matches between them. PlagScan does that, for example. So one of the methods actually did it, but we could have extended this more to a larger corpus. So yeah, that's about it. If you scan this QR code, then you will come to our lab webpage. There's a lot of research on plagiarism. It's more information retrieval driven, but now we're moving to NLP applications a lot. Also, you can check out my website, post me a message if you're interested in this work. And then, yeah, I'm open for questions. Thank you.